Hello, everyone. Let's get started. Please download Laboratory 29 multiple regression models today. So we will continue learning the linear regression model in multiple versions. So as usual, please run the first script to identify your host name, username, and current information. And actually, in last lab, I told you perhaps we will have some bonus labs for the lab sessions. But the professor thinks maybe it would be better we can select the maybe perhaps the best 27th or best 25th labs as your lab marks. So it means perhaps we will have 31 labs, but we will select your best scores of 25 labs or 27 labs. Okay, so don't worry about that. You don't have the bonus labs, but perhaps for some labs, if you don't get a good marks, it doesn't matter. Okay. Yeah. So. Okay, let's continue and run the first one and input your name, our number, title, and date. Today we are going to use another example to show the multiple linear regression model. Here is a hard data CSV file determine the effect independent variables biking and smoking have on heart disease. Okay, so first we need to load necessary packages. Okay, so NumPy, Pandas, Matplotlib, Matplotlib, statistics models, and then we need to get the data file. Okay, so here, I think our data CSV, this one, right? You can delete. Actually, it doesn't matter. So you can run it and refresh. Then you will see a new CSV file about biking, smoking, and heart disease. You want to find the relationship between the biking and heart disease, smoking and heart disease. Okay. So as we see here, there are 498 rows, 3 columns, and the first one is the index column, right? And after that, you can learn how to process the data. So first one, we need to read into a data frame, right? And here you need a good biking is miles per week, packs per week, smoking is packs per week. Heart disease probably hospital admissions per 100,000 for the combinations. So first one, you need to use pandas, read the CSV to read the data, right? Read the CSV, and then you can rename it. Biking as bike, smoking as smoke, heart disease as disease, right? And then show the first 3 rows as a sample. Okay, so about how to download the CSV file and how to read it into a data frame. Okay, so any questions so far? Okay, next one is we need to build a linear regression model, right? As we learned in last labs, we can build a multiple regression model, right? We can select multiple variables. In this example, we select the bike and the smoke, right? Bike and the smoke, and then data. We use the OLS, right? So and initialize and do the feed, right? And after that, you can get the intercept and the slopes, right? The first one intercept would be the slope, and next one slope would be the parameters for bike and the smoke. And after that, we can also calculate the R square and RMSE these two variables are used to measure how well a linear regression model fits the data set, right? You can write and then it will initialize and train the model. And here, actually, I think you can print, for instance, you can print intercept and print slope. You want to check the result, okay? Slope. Oh, it's only, yeah, so the intercept and the slope. So if you don't remember, you can check the results from here, right? It's a model. This is a model, right? So you can check the results and then it is a slope and the intercept, okay? And after that, you can plot the you can plot the a figure to show the actual data and your predicted data, right? So model predict, hard fill, and title. Here is a scatter plot as a blue dots. And then here is a red as a marker, regression line. Okay. So regression line is a red one, right? So because actually model observations and model predictions, it's about the it's about biking. X is a biking, and disease, hard field disease. I think this one is a little bit wrong, right? So and smoke disease. Okay. Okay, so it's in this example, in this figure, you see here, we use the bike and then the disease as the actual data, and then we use the model to use the predicted. That's why here the x-axis is the bike, right? It's bike miles per week, and then this one is blue dots. They are actual data, right? So you see they are very connected. So it means if you have more miles on biking, then it will have less probabilities to have a heart disease, right? It's a like negative relationship, and you can also plot them in plot the relationship between the disease and smoking, right? Smoke and heart fail, right? That again, so you see here, smoke and smoke as x-axis and the disease as the y-axis, right? And you can check the result, predicted results and the observations. Okay, so in this example, it's not very clear if you use the smoking and heart disease to show the relationships. Perhaps it's about the data set, but it is what you got in this example, right? So yeah, so right, so but for this one, for the biking, it's very clear, and you can see the R squared and RMSE, they are quite small, so it means the linear regression fits the data set well, right? And please learn how to plot two things together, plot the actual data and your predicted or the regression model in the same figure. It's very important, okay? So please remember how to write the codes to show that. Okay, so here we can set one, and you can see it's a line about this way, right? So because we use two things, bike and smoke in this example, all right? So that's why here we can use 0 to show the scatter plots on the actual data and the regression model, okay? So, okay, so any questions so far? Or do you have any errors when you run the cells? Okay, so this is an example about how to use linear regression model to analyze the heart disease example. Okay, so next one is about the summary. You can read the summary. And here is you can read all of them. It's very concrete, right? So dependent variable and R squared, just the R squared F value, and residuals method. So number of observations, how many rows, and time, method, right? Coefficient, standard error, P, and T. So actually, I'm not very sure about the last of four. I didn't use them. So actually, if you want to know all of them, you can check the menus of the summary. Yeah, so then you will know all of them. And yeah, they are quite useful. So you don't need to calculate them by yourself. You can just use the summary and get all the information about your model. Okay. Skewness, kurtosis, right? So okay, so next one is about two exercises. So first one, you need to interpret the results. Is there a correlation with smoking and disease? So perhaps you have a you know smoking is related to the disease, but based on your data, you need to write the answers based on your observations on the data, right? Correlation with biking and disease, and for here you see it's very clear, right? Which is the better lifestyle choice? Yeah, so if the goal is to reduce disease, how much better? And are the parameters significant? Non-zero, non-zero. Yeah, so it's about the first exercise. And next one, you need to second exercise is using tools from lab 28. You can review 28 plots, label the plots of the prediction intervals for disease index using spiking and smoking as predictors variables. So because in this one, we only use one variables as the x-axis. Okay, so that's why you need to use the using spiking and smoking as predictors variables. And yeah, so it's about the second exercise, right? So yeah. All right, it's a simple example, and that's all I want to share today. And if you don't have any other questions, please feel free to leave the meeting. And thank you guys. Have a nice day. And if you have questions, you can stay here. Okay.